This is a demonstration of the Sled Test Predictor. This obviously is in an Excel spreadsheet, so everything is transparent. From the top, you can see we have two payload options. They can be anything from a kinetic warhead or a bowling ball, or they can be more sophisticated, like a three-stage ejection seat shown here. Meaning that you can eject on a rail angle at a rail speed and then deploy different masses and drag coefficients and areas with time. You can see a quick display of the side view there for the payload trajectories. You can then move down to the 5 sleds that are available. You can see that each sled can pick from any cart in the sled library. That is user editable, so you can add or alter the masses and drag coefficients and presented areas. Then between each cart you have a selection of push rods, so you can have different lengths which adjust the aerodynamics. You can also have these push rods locked or to release. In the case of being locked, they are fixed between the carts. In the case of releasing, they work as bumper cars, just pushing. So you can see here events 1 through 10 represent the ignition possibilities, the 2 stages each on 5 sleds, while events 11 and 12 are the payload ignitions. Here's a side view with Hurricane Mesa Test Facility as an example in the background, illustrating the altitude and wind drift of the payloads. And being in Excel, of course, all of the options are available to plot anything versus anything. The example ones include overall views of thrusts and behaviors, as well as individual sled parameters that are tracked. But you can always adjust and add. In this case, here's a tab that shows some sample events where things occur and what was assumed. Here is an output tab that goes through every time event simulated, so thousands of rows, and parameters can be tracked thereafter for a full record of the event. And simplified increments, so every 100 feet down the track is another summary of the conditions of the sled at that point. Here's a look at the library of sleds, so any cart, masses and areas are editable there, and any motors, so up to 150 thrust versus time points can be entered, as well as the masses before and after burn. Here is the library for the payloads. So again, each of those has 3 options or 3 states that you can change the mass and drag behavior. Going back to the look at the motor options, you can pick any motor from the user editable library on any stage of any sled. So you have 5 sleds, each of which have 2 stages, and so you can go to each of those 2 stages on each sled and pick the motor you would like. After that, you can also go and pick out the number of those motors that you would like. So in one case, you may have 10 motors of one type and 3 motors of another type on sled 5, whereas on sled 4 you can pick any other type of motor at any count. So this illustrates how those can be input and manually controlled, and within seconds the simulation is complete following the user's input. Each of these also can fire at an ignition delay of the user's choice. The simulation will note where the motor would burn out, and then you can adjust the next ignition from the burnout before or after. The model also has auto-tuning features, so if you, in this case, you see everything is tuned the way the user wanted it, so you have all of the events occurring on the actual or simulated sled where the user wanted them, the speed and the downrange position. But let's go alter that. So instead of this arbitrary match where we have 10, 9, 8, 7, 6, 5 numbers of motors, let's set it to 2. And let's go set the sled back to 0 station, so it's all the way back at the beginning of the track. So now let's say at this point we want to tune the first stage quantity of motors to make the max velocity and keys match the target velocity, target C, on the left of 400 keys. So you click that button and it tells you how many motors to install so that you achieve that max velocity and keys. Then, given that suggestion from the model, you can round it up to an even number or adjust as you see fit. Now you go back, you're still not aligned on the track, so you can click that button and it will now move the sled to its initial position somewhere along the track stations, so that you not only have met the velocities that were set on your target, but also achieve those at the station of the track where you wanted, such as where your instrumentation lies. As you can see now, we are realigned here so that you can see or display the events needed where they are needed. This example shows that same type of simulation for a weather day. So you have a simulation, an entire set of sleds that were working well, but the test day the temperature was higher and the barometric pressure was lower, so you had less drag and less a chance to hit the keys you wanted. So you click the button to re-optimize the number of motors on that stage that you are targeting, and it tells you how many motors to add so that you can achieve your speed. Then you click the realignment button and it will move that sled to the position needed initially for the first ignition, so that the payload again deploys where you wanted to see it, or any other target, target A, target B, target C, any other feature that you would like to optimize, the model can do that. So let's talk about the 3 main tabs for the user inputs here. We'll have the Live tab, plus a sim selector, and the archive. So let's say we've done a lot of changes here. You can see just randomly putting in different numbers and different motors. So let's say that we've gotten to a spot where we just want to reset everything back. What we'll see here is a series of reset buttons. So when you click here, you're going to reset the sim selector, which we'll talk about later, to the default. Then you're going to reset the live console that we are looking at to the selected simulation. This also lets you go back and pick any sim from the archive to edit. Now you can see the warning. It says we must reset the sim selector to the live option in order for our live console to work again. And you can see what we're talking about. Now we've picked the sim selector tab. What is this? This is like in a studio, you are playing back any recording you like. If you have it set on live, then you will be listening to the live inputs. But if you would like to select anything else from a recorded track, then it will play that instead. So you can see here many different simulations that have been recorded as tracks for the archive. When you go back to selecting the live from the input console, then your input console will be the simulation played. But here is the archive. You can see the initial column in green is your live input console. This is constantly monitoring all the inputs the user is making on the live input console. And if you would like to record a configuration, you merely copy that column data into a new column in the archive, and you will have that memorialized. You can also set a default that you would like in the archive to be the populated values whenever you hit these reset buttons. So one way to think of these 3 tabs is as if they are a guitar. That is your live tab. The sim selection tab is like the recording studio. So the studio can be listening to you live, and that will populate all the graphs and the curves and the tables. Or the studio can switch over to be playing a pre-recorded track, in which case it will be ignoring the inputs you put on the live tab. And the third tab being the archive tab. That's your library of all of those pre-recorded tracks. So the way that would work is that if you are operating your live track and you get everything set up the way you like and the simulation is working properly and you want to make that a permanent track that you can refer to and play back, then you can go to the archive tab and you'll see in the live column that column of data can then be copied and pasted into a new track in the permanent recordings. Also, the reset live to the selected sim lets you invoke one of the archive tracks back into the live input screen, so you can then edit it as if it was an initial live scenario and save it later if needed. So again, to recap, this was what those reset buttons were doing. First, we reset the sim selector to the default. Then we reset the live version in the console to whatever was selected in the simulation. And finally, we set the sim selector to monitor the live inputs. And now you can see everything is back to the aligned and historically measured example that we started with. At this point, let's look over the transparency of the STP. You can see that each sled has its own simulation tab. Each of those transparently shows all of the equations and documents all of the numbers that are calculated. You also have a simulation tab for the push rods, so you can monitor the forces that are acting between the carts during the simulation, and the payloads as well. You can see that each payload has its own simulation tab, and that is explicit then on all of the features that are assumed and the trajectories that are created by that event.